Hi everyone, in this video we will be covering about the interpreter design pattern. So let's start with the definition. Interpreter is a behavioral design pattern, defines grammar and implementation logic used to interpret the expression of a language. So in simpler terms, it means that you might have a grammar. So a grammar can be a rule like for plus, there should be an expression at left, then maybe a plus in between, and then an expression at right. Right. So this can be a grammar. Let's say you want to somehow solve 3 plus 2, or how would you parse this thing? How would you like evaluate this particular thing? So in order to interpret the expression, so expressions like these inside a language, the interpreter design pattern provides a handy way to solve this particular piece of problem. So the problem here is you need to interpret or evaluate expression writing in a custom domain specific language DSL, such as arithmetic operation. So like I said, 3 plus 2, or you it can be boolean as well, 3 or 2, something like that. So you want to create a rule engine. If you want to do a rule engine like if a is greater than 3, do this particular thing, else if b is less than 3, do this particular thing. So without a lot of if else and like putting if this is plus and then doing something like parse this, that can be very challenging. So this is what the interpreter design pattern helps with simplifying. Structure. So in the structure we have few things. We have expression, so abstract class or interface. We have our numbers, and then we have two type of expression. One can be a terminal expression and other one can be a non-terminal expression. A terminal expression in case of 3 plus 2 would be 3 and 2 are terminal expression, since it doesn't do anything, it just returns 3, returns 2. And plus is a non-terminal because it is a combination, right? So 3 plus 2 would evaluate and then give you out a value like 5, right? So this is non-terminal expression. Context also we have, which is optional and hold some kind of like global information, which we won't cover in this part. Let's look at the code of interpreter design pattern. So we have created an interface of expression and it has a method known as interpret. We are having a terminal expression, which is a number. So what it is a simple just return that particular number. And we have a non-terminal expression like add and subtract. So inside add, what we have two expressions, left and right. And what we are giving out on interpret is left dot interpret plus right dot interpret, right? We don't have any if else case here in this scenario. Then we have a subtract one, which just changes the sign here, so it is negative here instead of positive. Now how would we use it is something like this. We have an expression, we create number 5 and 3 and 2, and our expression is add 5 and 3, so that would give us 8, and subtract whatever the result of add was with 2. So 5 plus 3 minus 2. So in this case, you will get 6 as answer. Let's try to run this piece of code and you get 6 as your answer. So this is all about the interpreter design pattern. I hope you understood it. If you like the video, do hit the like button and subscribe to the channel, and thanks for watching.